various terms related to wave motion. When we use the term wave motion, specifically we are referring to progressive wave, and in progressive wave we have to define what is velocity of the wave, that is the frequency, the wavelength, and the time period. So first of all, the point to understand is that when we say that the wave is propagating, we are referring to propagation of progressive waves. They are moving in the form of crest and trough, and we make crest and trough as a that is the image for that, and distance covered by the wave for one vibration will be known as the wavelength, whereas the distance between two consecutive crests or consecutive troughs, that will be known as wavelength, and the distance covered by the wave for one vibration, that is called wavelength. And if n vibrations are completed in 1 second, then one vibration will be completed in 1 over n seconds, and that is called time period. So time period means time taken to complete one vibration. Then comes the amplitude. Maximum displacement of particle from its mean position is known as amplitude. Now, there are certain definitions, as I have just now explained. The first definition is amplitude, the maximum displacement of a vibrating particle of the medium from mean position, that is known as amplitude. And in the general equation of SHM, it is indicated by y is equal to a sine omega t, where y is the vertical displacement, a is the displacement amplitude. It can be plus minus a. If it is plus a, means amplitude is increasing, and if it is minus a, amplitude is decreasing. And omega t stands for phase angle, and in this, omega can be taken as 2 pi over t, t capital, or otherwise 2 pi n, because n is equal to 1 over t. Now, next is periodic time, that is time taken to complete one oscillation or vibration, that is called time period, indicated by t. So time taken to complete one oscillation. And now this is a figure shown in which the crest and troughs are shown. So distance between two consecutive crests as shown by 2 pi over omega, that is wavelength. Similarly, distance covered by the wave for one vibration, that is, we have constructed a wave up to t in which there is one crest and one trough, and that is also equal to wavelength. So if we wanted to define time period, it is the inverse of frequency. So in this figure, a periodic time has been explained, and wave frequency, that is the number of vibrations made per second by the particle, and is denoted by n. So n is 1 by t, or we will find that the product of nt is 1, that is constant, and its unit is hertz. And 1 hertz is equivalent to 1 vibration per second, or 1 cycle per second. Angular frequency is given by function omega is equal to 2 pi n, and the unit is taken as radian per second. Wavelength is lambda, and that we have already defined, the distance between the two consecutive particles in the same phase, or the distance traveled by the wave in one period. It is represented by lambda. So again, the figure is shown, direction of propagation. From B, a projection has been drawn. The B is a point of maximum displacement, that is called antinode, and the points taken on the reference line, that is A, C, E, G, etc. These are supposed to be the nodes, whereas B and F is supposed to be antinode. Node is a region of minimum displacement, maximum velocity, the maximum kinetic energy. But antinodes are the points of maximum displacement, minimum kinetic energy or maximum potential energy, and velocity will be 0. And we find here that the distance between the two consecutive crests in the same phase is supposed to be the wavelength. Now, wave velocity we wanted to find, it is taken as n lambda, So basically, velocity is taken as distance over time, and distance can be replaced by one wavelength. So it should be lambda over t, but t is 1 over n, so it should be lambda over 1 over n. It will be n lambda, and this is what given in the relation. So v is n lambda, this is equal to lambda over t, and we can replace lambda by omega over 2 pi. So lambda over 2 pi is taken the inverse of k. However, k will be 2 pi over k. Therefore, velocity is given by function angular frequency divided by k. K is always taken as 2 pi, that is k, the value of k will be omega over 2 pi. So wherever we write omega over 2 pi, it can be replaced by k. Now, 2 pi by k if we write, or like omega over 2 pi is k. So if we take 2 pi over omega, it will be inverse of k. In the figure, the position of different particles at some instant in a string are shown. That is, string is allowed to vibrate. K is defined as 2 pi by lambda. So 2 pi by lambda, we are taking for omega over 2 pi. Wherever k is taken, k will be how much? K will be taken as 2, that is, we can take it as 2 pi by k. Now, intensity of wave, we come towards the intensity. Regarding intensity, it is energy per unit area per unit time normal to surface. And this we have discussed in our earlier concepts also. So, intensity in a medium, the propagation of energy perpendicular to per unit area per second. So, its unit will be obviously watt per meter square, and the alternative formula can be I is equal to 2 pi square n square a square rho into v. Rho is the density of the medium, v is the wave velocity, is the amplitude, n is the frequency, and I is the intensity of wave. So unit is watt per meter square, that is power per unit area. If V and rho is constant, then I is proportional to square of frequency, and I is directly proportional to the amplitude square. Now we come towards energy density. Energy density means energy per unit volume, and that is called energy density. So energy per unit volume means if E is energy and volume is V, then it is E over V, and V is supposed to be area of cross section into length. Energy density can be further modified to a formula, that is the wave intensity divided by wave velocity. Then we put the values of wave intensity and the wave velocity. Cancelable numbers we cancel, and the remaining number we write. So the remaining number will be 2 pi square n square a square rho. Now we come to wave pressure. Wave pressure indirectly means that wave is exerting pressure. Example is quite simple. That is, like human being, the mouth of the human being is working like a transmitter, and the eardrum is behaving like a receiver. So from the transmitter, the waves are generated. Through the particles, they reach to the eardrum, and there, those waves exert pressure. So when a wave incident on surface, then it produces pressure on it, and that is called wave pressure.